In this video, I will provide you visual examples of common metamorphic rocks. I'll describe the rocks by their texture and composition and provide protoliths as applicable. I will annotate or hover over the rock I am describing with this red laser on slides where there is more than one example present. Let's begin with slate, schist, and gneiss. These are all foliated metamorphic rocks. And this list is also in ascending order from lowest metamorphic grade to highest metamorphic grade. Phyllite is another foliated metamorphic rock that is slightly higher grade than slate. However, it is less common, and thus our discussion of phyllite is limited to this statement. It is not shown on this slide. Slate, schist, and gneiss all have common shale protoliths. However, schists can have basalt protoliths, and gneisses can have granite protoliths as well. Original shale bedding planes are enhanced via foliation and preserved in a slate. Observe the layers or the sheets visible in this slate example. Slate is widely used for construction materials. After higher temperature and pressure regional metamorphism, minerals recrystallize from microscopic sizes to macroscopic crystals, yielding schists and gneisses. Schists are rich in those sheety phyllosilicate minerals, for example, micas. Environmentally speaking, schists are prone to landslides because of the general weakness of the minerals and the planes of structural weakness from the foliation of the phyllosilicate minerals. Gneisses characteristically exhibit alternating bands of coarse, light, and dark minerals, such as these contrastingly light and dark bands, and these minerals separate out during metamorphism. Next, we have two non-foliated metamorphic rocks, marble and quartzite. Marble is metamorphosed limestone, regardless if the limestone is chemical or biochemical. Marble can often retain different color banding despite its non-foliated texture. And like limestone, marble effervesces with dilute acid. Economically, marble is coveted for statues, counters, and tombstones. Quartzite is metamorphosed sandstone, particularly quartz sandstone, in which the quartz grains recrystallize into interlocking crystalline textures. Quartzite is notoriously hard, and quartz-rich rocks, such as quartzite, are often used in glass making. The last of our metamorphic rock examples is another non-foliated rock, anthracite coal. In our last video, we learned about a sedimentary rock called bituminous coal. Anthracite coal is the product of the metamorphism of bituminous coal. Some consider anthracite the median between bituminous coal and graphite. Anthracite is non-foliated. It is shiny, black in color, and it retains no evidence of sedimentary beds. The process of lower temperature and lower pressure burial metamorphism has transformed any remaining plant material in the bituminous coal to carbon, which makes anthracite coal highly valuable for energy. In fact, anthracite coal has the highest energy output because of the high percentage, about 92 to 98% of carbon. Again, we will revisit anthracite towards the end of the semester when we discuss fossil fuels. So those are all the rock types we will focus on through the semester from an environmental geology perspective. Make sure to study the properties, the processes, and any environmentally valuable information from these rocks to do both well on exams and have background knowledge as we move through more complex environmental geology concepts. And as needed, review the rock cycle. That's all.